Welcome back to another episode of Engineering 101. Before we begin today's video, let's answer our trivia question from the last episode, which was, what's the secret reason we apply a vacuum during polyurethane vacuum casting? If you were paying attention, and of course you were, then you know it's not just to fill the mold, but also to force the entrapped gas molecules to shrink, thereby greatly increasing the density and strength of the finished prototype. And of course, stay tuned for a new trivia question at the end of today's video. Do you know the difference between insert molding and 2K overmolding? More importantly, do you know how these two related processes help you to improve the look, feel, and performance of your custom plastic injection molded parts? Today, we're delighted to give you a quick overview of each process, and we'll describe some of the benefits you'll want to consider for your next injection molding project. First up, insert molding involves placing a separate component, such as a nutsert or an electrical contact, onto a mounting fixture inside the plastic injection mold tool. During the production cycle, molten resin surrounds the insert and then solidifies, thereby permanently bonding the insert in place. What are the advantages for custom part design? Threaded nutserts are strong and reusable. That makes it easy for two or more plastic parts to be assembled and disassembled repeatedly without damaging the plastic substrate. There's no need to invest in special equipment or additional tooling fixtures, so that saves money. Inserts are protected against vibration. Inserts are electrically insulated by the surrounding material. There's no need for secondary machining processes. And inserts don't have the same design constraints as molded plastic parts. For example, they can be relatively long and thin and aren't subject to warping or thermal stress. Overmolding is another form of plastic injection molding. You'll sometimes hear this referred to as 2K or two-part overmolding. In this process, two dissimilar plastic resins are permanently bonded together, one on top of the other, the second one usually being a soft elastomer or rubber-like material. Designing the tools for overmolding is more complex than it would be for a single resin type, and the manufacturer may need to use specialized equipment, but there are some great advantages for certain products. The overmolded resin and the underlying substrate are permanently bonded during injection. That means there's no need to use adhesives or expensive secondary gluing operations. Because of this strong bond, the overmolded part is very durable even under hard use, such as with power tools. Soft, overmolded resins improve grip. Overmolds protect against vibration, heat, shock, and electricity. Decorative colors, designs, and company logos can be added to the overmolded component. There are a few different techniques for overmolding, and they may involve longer production lead times than with conventionally molded parts. However, the finished product can be substantially more attractive and functional and command a higher price in the marketplace. If you're not familiar with designing for insert molding or overmolding, we recommend working closely with your manufacturing partner at the outset of the development journey in order to get the best results. And for more information on this subject, check out this link to our related serious engineering video. Okay, as promised, here is today's manufacturing trivia question. What is the clamping pressure of the world's largest injection molding machine? If you think you know the answer, please reply in the comment section below. And remember to like us, ding the bell, and consider subscribing. Thanks for watching, and we'll see you next time with more manufacturing insights from Engineering 101.